Alright, hey guys. Today I'm going to be going over question 6 from the paper 1 November 2009 exam. So the question consists of solve cos 2x minus 3 cos x minus 3 minus cos squared x is equal to sine squared x for the domain of 0 is less than or equal to x, which is less than or equal to 2 pi. So before diving right into this solution, we must firstly know the double angle formula, which is cos 2x is also equal to cos squared x minus sine squared x, or 2 cos squared x minus 1, or 1 minus 2 sine squared x. Now moving on to the trig identities, it is important that we know cos squared x plus sine squared x is equal to 1, and that sine squared x is equal to 1 minus cos squared x. We'll be using this one and this one for the solution. So applying the trig identities to the problem. So we're starting off with this problem, and it would be ideal that we get all these values, all the values that we can, equal to cos squared. So to do this, we'll first be changing this value using the trig identities to get 1 minus cos squared x. And then we'll be changing this value right here to get 2 cos squared x minus 1 using the double angle formula. In simplifying this, we get 2 cos squared x minus 3 cos x minus 5 is equal to 0. And now that it is in standard form, we can factor this to find the x values. So, how to factor 2 cos squared x minus 3 cos x minus 5? Firstly, we make it equal to 0, as seen here. And we find the a value, b value, and c value. In this case, it is 2, 3, negative 3, and negative 5. Now we need to figure out what a times c is, and that is equal to negative 10. So we need to determine what values can add to negative 3, the b value, and then multiply to negative 10, the a times c value. And we figure out that that's negative 5 and 2. So we apply the negative 5 and 2 to the original formula where the negative 3 once was. As we can see, 2 cos x minus 5 cos x is equal to negative 3 cos s. But in doing this, it allows us to factor the equation. So to factor this from here, we see that there's a common value of 2 cos x in this part of the equation. So we factor out 2 cos x, which gives us cos x plus 1 inside the brackets. And also, in this part of the equation, we see that there's a common factor of negative 5. So we factor that out to also get cos x plus 1. Now, we can further factor it by bringing together common terms to get 2 cos x minus 5 times cos x plus 1. We once again make this equal to 0, and from here we can determine the x values. So from here we know that cos x, if it is equal to 5 over 2, it will equal 0, and thus make this entire equation equal to 0. Thus we know that if cos squared x is equal to 5 over 2, that is one of the cos x values. Or if cos x is equal to negative 1, negative 1 plus 1 will also equal 0, and that will make the whole equation equal to 0. Now we are dealing with two cos x values, and we got to determine which one to continue on with. Immediately by looking at this one, we see that, or we know from previous knowledge that cos x is equal to the adjacent side over the hypotenuse. And it is impossible for the adjacent angle to be bigger than the hypotenuse, and in this case 5 is greater than 2, so we know not to use that value. Moving on, we know that cos x is equal to negative 1, and therefore we will use this value to solve the rest of the problem. Now it's important to take into account the domain. The domain states that 0 is less than x and less than 2 pi, or x is less than 2 pi. So through using this, we see that from previous, we know that cos x is equal to negative 1, giving us the horizontal value of negative 1. And from here, from using the trig circle, we know that -1 is equal to pi, and therefore we can conclude that x is equal to pi. Thank you.